Welcome back. In today's lesson, we're going to combine the graphing method, substitution method, and elimination method for solving systems all into one learning target. And what I'd like you guys to be able to learn today is how to pick which method works best, which is the easiest method if you're given the same system. So I'm going to go through three different types of problems: the graphing efficiency, the substitution efficiency, and elimination efficiency. So let's first start with graphing efficiently. So I've given you a system, A, B, and C. You'll notice that each system is the same. So this system is the same as this system, the same as this system. And we're going to solve it all three ways. So for the first way, for graphing, I've got to turn this into y equals mx plus b. So I'm going to have y equals negative 2x plus 8. I just subtracted the 2x over. So I'm going to graph this equation, and I'm going to graph this equation. So the first equation, I'm starting at 8. I'm going to graph that in red. So I'm going to start at 8. My slope is negative 2 over 1, so I'm going to go down 2 over 1. And I'm going to make dots all the way across the grid, because if you remember in the graphing method, you've got to figure out where that intersection point is. Connect my dots, make a really nice straight line. And then I'm going to graph the second one in blue. So I'm going to start off at 1, and I'm going to go up 1 over 3. And boom, I can see my point of intersection is right there once I connect my dots. So I'm going to connect my dots. And I found my point of intersection right here that I've highlighted, and that's at the coordinate pair 3, 2. So I found my solution using graphing method, and that wasn't too bad. I just had to rearrange the y, get y alone for y equals mx plus b. The second one, I want to do substitution. So I notice here that y is alone, so I can go ahead and take that right here, that fraction, and plug it into the y here. Now, we've never used a fraction to substitute, but we're going to try it out. We can do hard things. So I'm going to go ahead and replace the y with that 1/3 x plus 1. So I'm going to keep the 2x plus 1/3 x plus 1. That's what I'm replacing the y with, equals 8. When I combine these like terms right here, because these terms are like, 2x and 1/3 x, when I add those like terms together, I end up getting 7 over 3x. Bring down that 1, equals 8. I'm going to subtract the 1 on both sides. I can make my line here. Those cancel. I get 7/3 x equals 7. This is kind of a pain though, right? Like, I'm using fractions. It's not a whole lot of fun. I'm going to have to multiply both sides by 3 to get rid of the fraction, which is kind of annoying. I get 7x equals 21. Divide both sides by 7, and x equals 3, which is good because that is exactly what I got over here for x. X is 3, x is 3. But with substitution, I now have to go back into the problem and plug the 3 in. So I'm going to go ahead and pick this second equation. You can come in and sit down. I'm going to go ahead and pick this second equation right here, and I'm going to plug the 3 in. So I get y equals 1/3, plug that 3 in from right down here, plus 1. I've got that fraction again, which is a pain, right? Like, we kind of want to avoid fractions, except in the previous example with graphing, that fraction was nice because it was just slope, and we could go rise over Rome with that fraction. But in this case, we're going to have to use our calculator or use our minds and do 1/3 times 3. That's going to give us a 1, and 1 plus 1 equals 2, which is good because that's what I got over here, what I'm going to highlight. I got 2 over here for my y, so notice that I got the exact same answer, except it took me way longer to get there. So in this case, so far, graphing seems like the easier option. For part C, we're going to solve by elimination, which is going to be really challenging because when we do elimination, we have to line up our x's and y's. So for this, I'm going to go ahead and rewrite. I'm going to keep the 2x plus y equals 8. But I'm going to rearrange the bottom equation, so I've got the x on the left side. So I'm just going to subtract that 1/3 x over. And I end up getting negative 1/3 x plus y equals 1. Got to do kind of a painful thing here. I'm going to have to multiply this bottom equation by negative 1 because I want those y's to eliminate. When I do that, I end up getting 2 more equations. Notice how much harder this is. And I get positive 1/3 x minus y equals negative 1. The y's cancel, which is what we want, but now we've got to add 2x plus 1/3 x. We end up getting that 7 over 3x again, equals 7. Multiply both sides by 3, 7x equals 21. Divide both sides by 7, x equals 3, which is again is good because that's the x I'm getting each time I do this. But notice for elimination, it took me way longer to get there. It was a huge pain. I gotta still plug that x equals 3 in. I'm gonna pick that bottom equation, y equals 1/3, plug that 3 in. Y equals 1 plus 1, which gives us that 2. So for each method, I still got the same solution, but boy, graphing was easier. So notice, I think the theme here is that when you have a fraction in front of your x, think slope, think y's overrun, instead of thinking of substitution or elimination. Let's take a look at substitution efficiency. So now I'm gonna have the same system for a, b, and c. Okay, I've got this x minus 7, x equals 7 minus y, and 2y minus 3x equals 4. Same system for each one of these, and we're going to go ahead and try using each method. The graphing method right here, I'm going to write the word yikes right here. And I'm writing the word yikes because notice neither of these equations are in y equals mx plus b. So we're going to go ahead and turn them into y equals mx plus b. For this first equation, I'm going to go ahead and move the 3x to the other side. So I'm going to go ahead and have... I'm going to subtract that 7 on either side. So I get x minus 7 equals negative y. Divide both sides by negative 1. And I get y equals negative x plus 7. So that's my first equation here. The second equation, I'm going to go ahead and add the 3x over. I get 2y equals 3x plus 4. Divide both sides by both sides by 2, but you're dividing everything by 2. And y equals 3 over 2x plus 2. Boy, what a pain that was, right? That was no fun to try and get those y's alone. But now that they're alone, we can go ahead and graph. Y equals negative x plus 7. I'm going to make a dot here at the 7. Go down 1 over 1. And it's negative. Connect my dots here. Make a nice, neat straight line. And then I'm going to do the other one. Make my point at 2 and go up 3 over 2. 1, 2, 3, and boom, there's my point of intersection right there. So I found my point of intersection. I found it right here at 2, 5, but it was a real pain to get there. That was not super fun. So maybe when we have x and y on the same side, the graphing method isn't as great. But substitution, however, I can notice that on substitution, I've got this x alone right here. And that's fantastic for substitution because that means on the other side, I can take that 7 minus y and plug it in for the x right here. So I'll highlight that, taking the 7 minus y and plugging it in for x. When I do that, I get 2y minus 3, big set of parentheses, 7 minus y equals x. Okay, and now this is a lot simpler. I can just distribute, get 2y minus 21 plus y. Notice, nope, sorry, that's 20, yeah, I did that right. It equals 4, not x. My bad, makes a mistake. It equals 4, not x. So it equals 4. Add the y's together. 3y minus 21 equals 4. Add the 21 to both sides. I get 3y equals 25, divide both sides by that 3, and I get that y equals, oh, that should be a 5. Wow, I'm making tons of mistakes here. Yep, that should be a 5. Divide both sides by 5, and I get y equals 5, which is what I want, because that's the 5 on the other side. When I go ahead and plug that 5 into the top equation, I get x equals 7 minus 5, and boom, there's my x equals 2. So I still get 5, 2 for my answer, but that was so much easier. So substitution was like, yes, please, let's use substitution for this. For elimination, we've got to get those y's on the same side. So I'm going to go ahead and rewrite this as, oh no. I'm realizing I think I have the wrong thing. Okay. Anyway, I'm sorry. I'm going to keep going here. So I'm going to go ahead and add the y to the other side. X plus y equals 7. Line them up. And then I'm going to go ahead and put that negative 3x plus 2y equals 4, line them up. And now I can go ahead and try and eliminate. I'm going to have to multiply this top equation by 3 to get the x's to cancel out. So 3x plus 3y equals 21. And then negative 3x plus 2y equals 4. Add these together, 5y equals 25. And notice I still get that 5 for my y. When I go to plug that in, I get x equals 7 minus 5, and boom, there's my x equals 2. It was still kind of a pain, though, because I still had to get those x's and y's to line up. So in this case, when you have a variable alone, like this x right here, substitution is the way to go. Okay. All right, last one. We're getting to the end here. Elimination being efficient. So notice that every system's the same again. That negative 3x plus 7y equals 21, and negative 6x minus 8y equals negative 24. The same one. Now let's solve this by graphing. I'm also going to put a yikes here. And if you're thinking about y, we're thinking about that because we don't have y alone here. We don't have y equals mx plus b. So we're going to have to get that y equals mx plus b. So I'm going to go ahead and rewrite this. When I rewrite this, I have to write 7y equals, I'm going to add the 3x over and get 3x plus 21, divide everything by 7, I get y equals 3 over 7 plus 3. The other one, add the 6x over, 8y equals negative 6x minus 24, divide everything by negative 8, and boy, is this taking a lot of time, right? Like this is not very efficient. And this becomes 3/4 x plus 3. Kind of a pain. But now we can graph it. What's in y equals mx plus b. So I'm going to graph the first one in red. Start at 3. We're going to go up 3 over 7. We have a point right here. Down 3 over 7. We have a point right here. Connect your line. For the other one, I'm going to graph that one in blue. I start at 3, and there is automatically my point of intersection. That's fantastic. That's easy. The y-intercept's the same. But we can go ahead and make a few more points to make our line nice and neat. But I can see that my point of intersection is at that 0, 3. So that should be my solution here at 0, 3. Kind of a pain, right? I had to get y alone both times. Not super fun. So solving by graphing when x and y are on the same side is not the most efficient way to do things. Substitution is in a similar vein here. If I want to try and get x or y alone, I'm going to take that first equation right here, and I'm going to add that 3x over, and I get 7y equals negative 3x plus 21. I'm going to get y alone just like I did with graphing. Y equals negative 3 over 7x plus 3. And now what a pain this is, because now I've got to substitute in something with a fraction. And fractions are great for y equals mx plus b in your slope, but they're not super great when we substitute because fractions are kind of a pain, right? But we're going to go ahead and show you anyway. I'm going to plug that into the y. I'm going to get negative 6x minus 8, and then in parentheses, I'm going to put that negative 3/7 x plus 3 equals negative 24. I'll help you out. I'm going to tell you that negative 8 times negative 3 over 7 is 24 over 7x. Yikes. Again, I'm going to keep saying that word yikes because this is a yikes. I'm going to add these two like terms together, and when I do that, I end up getting negative 18 over 7x equals, if I add the 24 to both sides, those cancel and I get 0. Well, anything times 0 is 0. If you have negative 18/7 times 0, you're going to get x equals 0. Which makes sense because that is the same answer I got when I graphed. But now I've still got a big pain here. Now I've got to substitute that 0 back in. So negative 3 times 0 plus 7y equals 21. The 0 cancels. 7y equals 21. Divide both sides by 7, and I get y equals 3. But look how much work that took. That took a lot amount of work. So maybe substitution isn't great when x and y are on the same side. But elimination is going to be super easy here because x and y are lined up. And as we learned in the last lesson, all we need to do for elimination is get the same value opposite signs. So I'm going to go ahead and multiply this first equation by negative 2. Because then I will have a positive 6 on top and a negative 6 on bottom. So this becomes positive 6x, negative 14y equals negative 42. And on the bottom, negative 6x minus 8y equals negative 24. Add them together and look at that. Those eliminate. And now I've got negative 22y equals negative 66. That divides really easily, unlike those fractions. And I get y equals 3, which is great. That's what I got in the other solutions, only that took me way less time. Now we're just going to plug that y into the 3 in for the y. Negative 3x plus 7. Times the 3 equals 21. And I get negative 3x plus 21 equals 21. Subtract the 21 on both sides, and boom, there's that negative 3x equals 0. So x equals 0. And I get the same answer of 0, 3, but wasn't that so much more efficient? So the goal of this lesson is to look at the problem you have in your practice and decide what method is the easiest: graphing, substitution, or elimination. Okay. I know this video was kind of long. You guys did great. Good luck on your practice, and let me know if you need help.